a lot of long streams, and some people tell me that they like the long streams and they don't want the edited content. I much prefer to watch really short things or to watch things at high speed. And so the kind of videos I'm making are not the kind of videos that I would like to watch. And I don't know. I really like the shorter, compact things, but you have to do all that work to, make the content in the first place. And that's what I'm streaming. So I would much, prefer to make some short videos. Editing is hard. And so instead, I'm trying this idea here. So earlier today, I filmed like 2 hours of video working in Smalltalk on drawing a particular data structure. And this video is going to be a recap of that. So kind of hopefully get it short and to the point. It's almost midnight here, so I'm going to try and get it wrapped up in the next 20 minutes here, and let's see if it happens. Let me just transition to the scene here. All right, so this is the video I did earlier today, Mondrian live coding, and it's called Mondrian because I'm using a library called Mondrian to draw this little graph structure that I'll show you in a bigger view in a second here. So just to recap what I've been working on in general, I'm working up to making some animations for what I call my main channel. Maybe this is my main channel right now, but the idea is that I want to make animations that go with my scripted content, right? And generally, I do videos about programming, so math or programming, whatever. So these would be things that are drawing, diagrams and whatnot on the screen, or just animations on the screen. I've done some work in Godot and to do animations, and I really like it, but I really want something more powerful for the kinds of animations I'm doing. So I've been looking at like just a lot of different tools, and this is a Smalltalk environment. So Smalltalk is a language that comes with like a graphical environment. This is what you're looking at here. This whole screen is a tool called Glamorous Toolkit. It's a very modern Smalltalk environment. It's got some very new ideas about how development works. For example, you can see my notes that I'm taking here. This is kind of like a wiki, like a document database structure right here. I'm taking notes right in here. I've got inline Smalltalk code that I'm going to fire up in just a second. And in fact, I'll just do it right now. I'll do it on this side. I'll do it down here. Okay, so, excuse me. I'll click that little arrow. And then if I click this button here, I'm going to get my a demo that I made earlier. And so this is, so everything you see, in this white area is something I've written today in preparation for this talk, like in the past couple hours since I finished the video. And then in this box, you're seeing I'm actually running the code that I wrote earlier. So the general, this is like a gallery of demos that I'm doing. So I've defined a class, and I've got a bunch of demos here, and these are little methods that are on that class that say like, how do I make views? And then Glamorous sees this thing is called a pragma, sees this line and says, oh, that's an instruction for me. And when I inspect this class with this little inspect button, I'm going to add these tabs up there. So I'm telling it to put my demos in these tabs. Right. So now I've got these are the demos for a library that I'm calling, or that it was actually some code I wrote in processing Java, like about 12 years ago, the very first thing I ever uploaded to YouTube. It was a series of demos for like a game programming course. So the idea is that you make, what I thought was that these demos make a pretty good like encapsulation of like interactive graphics, right? So the first one is the overlap demo, where you just you have some boxes, you drag them around, and then you just detect whether they're overlapping. So this makes you, whatever graphics framework you're using, it makes you get arrays worked out. It makes you get things on the screen. It makes you get geometry working, and mouse interaction, and then changing colors in real time and all that kind of stuff. Here's a button that says hello. So this is kind of like my framework, and then there's a generic framework for drawing, this little toolbar up the top, and then a scene, and then the actual graphics is coming as a library, or it's built on top of a library that comes with Glamorous here. All right, so that's the overlap demo. And then the next one adds animation. That's the bullet demo. You're actually supposed to have some of those little squares and you're supposed to shoot them. But since I already covered collision detection here, you just imagine it. So now you've got some bullets that you can fire. And so, you just, wherever you click, you've got that position, and then you're shooting a bullet. All right, so that's like the extent of it. And once you've done those two demos, you should be able to build like all kinds of like, you should know enough to be able to build a whole bunch of things. Actually, the next demo in the thing I did 12 years ago was a little Space Invaders game, but and I'm probably going to import that here because one thing I haven't done is put images in the scene and animate those. But I'm more concerned right now about making these making these animations for my videos. So that's what led me to tonight's stream. So tonight I made this, and it's the start on an animation. So I've got, this is like the first scene of the animation, and this is the second scene of the animation, or the keyframe of the animation. And so I've got this array of numbers, and I want to turn it into this tree of numbers. Let me see if I covered all that. Yeah, so this is a data structure that I call a path map. As far as I know, it doesn't have an official name. In a very limited set of circumstances, some people call it an Onentafel, but that is an awful name. And I'm making a whole video about why you should call this a path map instead, and like proposing this as a name for the data structure. Yeah, so that's it. And let's see. So if you look up on Wikipedia, if you want to see this, you can go to the binary trees place, and then for whatever reason the links don't exactly work here, because they add an extra character at the end. But if you go to arrays here, so this is the on that same page. This is the idea. You've got a set of numbers, and you've got an array, and you're going to store a tree in that array. Maybe I'll make it a little bigger. Oops. You're going to store a tree in that array, and you don't need to put any links. You don't need to put a child link or anything like that. It's all implicit. It's done by indexing. So the root is node 0, and then the one child is number 1, and the other child is number 2, and then this one has there's a calculation you can do that you can go from any particular node to the 2 children. And it's these it's these 2 polynomials, so 2i plus 1 or 2i plus 2. And then if you're in some archaic language that uses 1 for the base of an array, the first slot in an array, then you would use this one instead. Yeah, you would use, so you use 2i and 2i plus 1. Coincidentally, we are using I'm joking about it being archaic. It's just a choice whether you start with 0 or 1, and Smalltalk starts with 1. And so I ran into some issues with that. So, but we'll see. Right. So this is the basic idea, and the goal for the animation was to like take this and draw these arrows. And I kind of took a left turn here because I don't yet know how to draw. I know I've seen these drawn in Glamorous Toolkit, but I don't know how to do it. I don't know how to do the animation part. So I decided to just first start with drawing this thing. And so, as you can see, I got there. That's where I stopped, and I wanted to make this recap that it talks about how it works. Okay, so not just for binary. I guess I should point that out. So I'm gonna this arrow is pointing over here. So when I inspect it, it's going to make this whole area on the right-hand side now. And it did not do what it was supposed to do. Okay, well, I'm not going to debug that too much. Maybe I'll do a little quick thing. I'll just jump into the code because the thing is, this is how this code works. So I'll just show the code real quick. So let's actually, if I click this button, I get a new copy of it over here, and then I get the code over here. So this is the code. These are all the methods I've created on this class. You got make UI to like just make this whole instance. If you notice the other ones, they had like that toolbar at the top, this toolbar here, and then this one doesn't have it. So the UI is overridden to do that. The start scene is just says make these two things. So make a horizontal pane, add this thing on the left, it's this thing on the right, and they're both calling make graph. And then they're passing in a layout for how to do that. So that's the whole scene there. That's how you make scenes in this graphics toolkit. It's called brick or block. Block is the low level thing. Brick is the higher level widget and layout system. So that's the scene, and then the most of the code here is in this thing. I can actually fix this. I can say if 4 and 3 and save this. So instead of a binary one, I can change that to depth 4 or degree 4. So 4 nodes, 4 children per node, and so you get different structures. Okay, but let's put it back and let's talk about So the first thing is I need to figure out is how many nodes are there. I thought it was going to be a power of 2. I guess my head's in the way, isn't it? So let's make my head tiny so I have a little more room. And so how many nodes are there? And I thought it would be a power of 2. So I thought, and I'm wrong. And it turns out, well, so when you got a binary tree, you've got 1 at the top, you've got 2 on the next row, you've got 3 on the next. Oh, sorry, you got 4. Let me make this horizontal. So we'll call this whatever. Make this a vertical pane, and I'm going to make these. Come here. One horizontal, the top one horizontal, and the second one a tree. Okay, so let's run this. Boom. Okay, and then maybe I don't even need the top one. Yeah, because we're not actually doing this demo, so let's just look at the top. Okay, so when you're doing this, you have 1, 2, 4, 8, 16. You're doubling it every size, and then if you have 3, right, then you're tripling it every size. And so when you're doing this, I made the observation that it's 1 plus 2 plus 4 plus 8 plus 16, which if you write it in binary is 1 1 1 1 1. You just keep adding ones to it. And then if you write it in base 3, well, it's the same thing. I was mistaken in the stream, and I was saying, well, it's whatever, but it's you do it like this. Sorry, with 3, you got to save this thing, and then you do it with 3. That's hard to see, isn't it? Let's do it 3 levels deep. Actually, I think you can zoom in that way. So you got 1 at the top, then you got 3, and then you've got 3, 3, 3, so you got 9. So it's your powers of 3. And if you write that in trinary, base 3, it would be 1 1 1 1 1 1 1, right? And if you had 10 nodes, it would be 1 and then 10 and then 100 and then 1,000. So it would be 1 1 1 1 1, and same thing. So the question is, how do you go from these two numbers to calculating that number? I know how to do it as a string, but like how do you do it? So that was my first task. And so when I went into this, I wound up with this code. This is the actual code for the the whole calculation is here. So what we're doing is this. So okay, so here let me get back to my my script here, my notes, because I what I did is I knew I could write it like this, which is pretty much how I'm sorry. This is first of all, this is just calculating how many nodes there are. So that one I did do that. Wait, am I confusing myself? Oh yeah, this is a simplified version of this, right? So here I was saying, well, I could just you know, add those layers. So I could take you know, 3 and 7 or whatever I want them to be, and I can say, okay, from 0 to that number, collect the degree. The degree of a graph is how many children are at each level. So this is the 3 or the, you know, the 2 or the 3 or whatever it is, the you know, the base, and then this is the power. So the base to the power of I, right? And we're going from 0 to 1. This is a thing you could do in J in one line. So this is 3 to the I dot 8, and you get this sequence. So if you're in base 3, then these are the first 8 ones. So it's always 1 and then 3, and if you wrote that in base 3, that would be, these are all powers of 3, right? That's what it's saying. Take these numbers and then go to the power of 3. And then, so this is the Smalltalk translation. So Smalltalk is not nearly as concise as J, obviously, but it can be concise. But also, I thought, well, you know what, this is, and then also you have to add these numbers up. So this is the running sum of those things. So this is the number I actually want. And so the trick I did, which I thought was neat, whenever you see this is my advice to anybody who has to deal with sequences, and this happens a lot in J when you come up with this, you give it to the Online Encyclopedia of Integer Sequences, OEIS, and you just paste it in. You just copy and paste it, and it tells you what it is. And so I found that, and I typed in the one for 4 as well. I didn't copy and paste it here. I'm not going to fire up J right now. But when I did that, I realized, you know, there was a pattern, right? Oh, I'm sorry, this is 3 to the n. All right, so I need to paste this number in. The sums of 3 to the n. So now you can see that. I linked the wrong thing. So it's 3 to the n minus 1 divided by 2. And when I put it in for 4, the same thing with 4 here, it was 4 to the n minus 1 divided by 3. And that's the thing. And so that tells you, you know, for 2, it would be 2 to the n minus 1 divided by 1. So you just cancel out 2 to the n minus 1. So it's like 1 less than a power of 2. And that's exactly what 1, 1, 1, 1, 1 means in binary. But this is a start on the general thing, and the actual thing is, you know, the actual algorithm winds up being this. So degree to the depth, right? And so Smalltalk also runs left to right. So it's degree to that power, and then after you calculate that, then you subtract 1, and then you divide by the degree minus 1, and then because you're going from 0 to that number, you say minus 1. So well, we'll get to that in a minute. So I wound up doing 0-based indices, even though Smalltalk itself is base 1, and I was expecting to work in an array. Actually, wound up I'm not working in an array at all, because Mondrian just takes the, you know, I just made these numbers, right? This is just counting. So 0 to this, whatever this number is, this is the number of nodes, and then just count from 0 to that. That's like I dot 8 or whatever in J. So this is 0 to whatever minus 1 is I dot whatever in J, right? So this is just a list of numbers, of sequential numbers, 0, 1, 2, 3, you know, what I would call natural numbers. Some people would say natural numbers start with 1. So, and then, so that's X's. And then I just say, well, okay, you just say Mondrian. So Mondrian is the layout engine for making graphs. And you just say, well, you make this shape with these inputs. And so it just, like, yes, there's an array here, and slot 1 has a 0 in it, and slot 2 has a 1 in it, but it doesn't matter, because it doesn't care about the array indices. It just cares about, here's your data, and for each one of these data, I'm gonna data for each of these data. That's a weird way to say it. For each one of these items, I'm going to take that item and just make something. So this is something that makes a little box with a circle in it. This is You know, it's a class I made before. I really like, so this feature of this user interface is they have these little arrows here you can open up, and just right in the middle of your code you can see other classes and other methods and whatnot. So bottom line, this is it's got a foreground and background, it's got something in it, and it draws that thing in a box. That's it. And made it make gold colored, and that's the shape that gets rendered. And the way this works, another feature of Glamorous Toolkit here is that there's one rendering tree. So you can mix text, or you can make your own objects, and just everything gets laid out no matter what you want. So it's you can put pretty much anything. You can put forms, or one of these things, any one of these little text input things, any buttons, whatever you want to do. Mondrian can lay out any of them. And then it has the idea of making edges. Also in Smalltalk, I'm passing in 2 arguments here. So the name of this function is make graph layout, and it's got colons here. So the 2 arguments go after each colon. So make a graph, and there's a Boolean saying whether it's connected or not, and then there's a symbol which is something I'm going to pass to Mondrian to tell it, like, how do you want to lay it out? And that was the tree, or the horizontal tree, or whatever that I was playing with a little while ago. Okay, I see I'm actually at 30. It's a little. I'm 21 minutes now, so I'm going to wrap this up pretty soon. All right. So anyway, this is the system, and it makes cells that are gold and has a label for each one. And then if we're connected, then we're going to draw the edges between them. And that's just something I'm going to do in the animation, like start drawing one at a time. So probably, a simple Boolean is not quite enough. Like, I probably need to say, like, what step are we on, and something like that. But I'm not there yet. And so right now I'm just saying, well, 1 to degree. What I was going to say is there are no control structures. The control structures are all done with these blocks. So these square brackets are blocks. And so we say, here's a Boolean. It's either true or false. And it understands the method if true. And if it's true, it'll execute this block, which just says, from 1 to degree, do this, and then there's the connection. All right, so that brings me to figuring out how do I go from a node to its children, and you calculate them, and these are the things I showed earlier, right? And this is a complete. I put them in a Pharaoh block. This is just a complete little tangent, but I thought this was cool. This is for something else I'm doing, but I evaluated this. This is something I added to Smalltalk. Right, so I added a method called x to a small number. Like, if I look at this, right, I've added small integer. This says kernel small integer. I've added this method. It's in the package, or it's in the. I'm not sure what this is. I think it's a little tag or whatever. That's not the right word, but it's a category for this method. And it says star.tangent or star tangent store, meaning it's my package. It's an extension method that I added from my package. And it says return a line equation, a new line equation where m is set to self. So whatever this number is, 2, this is going to turn into a line equation, which is mx plus b, right, from algebra, right? And the m is going to be this number. So this is 2x plus 0. As soon as you evaluate this, you get 2x plus 0. This has nothing to do with anything I was doing. I just stuck it in here. I thought this was cool. So there it says a line equation 2x. And then, yeah, that's for something I'm working on. I just thought it was really neat that you could do that. You can just add something to the language. It's dangerous, and it makes me think of all the terrible things that happened in JavaScript when, people made frameworks that do this. And it makes me realize, why Smalltalk seems to have a problem where, no 2 projects want to work together in the same image, but it's neat that you can do it. So it's like it is really much a personal programming language and environment. So you can make it do whatever you want. I thought that was neat. Anyway, these are the equations that I got out of that Wikipedia page. Just 2x plus 1, 2x plus 2. Those are the indices when it's a 0, and when it's one index, it's 2x plus 0, 2x plus 1. And then I tried the same idea for 3. I thought it would be, 3x plus 1, and 1 and 2 and 3, and that was fine when it's 0 indexed. But when it's array indexed, It's actually 3x plus -1, 3x plus 0, and 3x plus 1. Because if you want, well, let's draw it, right? Right. So, you know, if this were a 1, you'd want it to go to 2, 3, and 4. Just, I mean, you want this exact same structure. You just want the labels to change. So how do you go from 1 to? I mean, I can make it show that, right? I can make it show that just by changing the label, right? So cell for I plus 1, right? And let's just okay, so how do you make it do this? Well, to get from 1 to 2, using the number 3 as a multiplier, you have to say 1 times 3 minus 1. 1 times 3 plus 0. 1 times 3 plus 1. So that was weird. I thought that was very, very strange. And that was something I did not know about this data structure. I did not know that about, and so that'll be in the video. Probably explore that idea a little more. Anyway, that was it. And then that was all the calculation I needed to. And so I take this array of numbers and I say, hey, make a new Mondrian, a GT Mondrian. Here are the nodes. Make the shape out of them with this data. And then if you're connected, then draw the lines. And you just say, it's kind of a nested loop here. So for 1 to the degree, you make 1 line per child. So this is for each child. And then, edges connect from, okay, value is like one of these, is like a block. You can always send a message to an object and just call it and just say value. So whenever you can pass a block in, you can pass a message instead. Because they both, whatever. And so this is just saying, like, from yourself to, in fact, I think you can actually say yourself here, I believe. But if you say yourself, it works. I know I'm getting off topic, and I'm making this even longer, and I wanted it to be short. But hey, you don't call me Tangent Storm for nothing. Yeah, it worked. Okay, so that's cool. From yourself to this other number, and then degree times I plus j. So I could have passed in like a polynomial here, but like this is that polynomial. And because I'm doing it this way, I'm doing the zero-based way. Right. So then there's the 1, the 2, and the 3. That's the 1 to degree. Do something, and then yourself to degree times x plus 1. So the 0 index is much, much simpler. Wikipedia said this was simpler, and it is when it's base 2. But when it's base 3 and 4, it's like you have to calculate all these weird offsets. And I imagine when it's 4, it's going to 4x plus -3 or 4x minus 3 or whatever. Anyway, so that's that. And then Mondrian lays it out for you. So that's the drawing part. This whole system is self-documenting. So if you ever download it, you can get all these examples yourself and try it out. And then what's left is animating. So that's it. That's what's ready for next time. That's the plan. So that'll be the next video, and that's it for this one. So what do you think of this format? Yeah, so like I said, this is an experiment. I know I'm talking fast. I'm not going to edit this. I don't like editing. I'm going to try and just get better as a public speaker. And so make something first, and then do a presentation. And if it takes me half an hour, that's it. So, and when I was shooting for 5 minutes, I'll work on that. Hopefully this was I believe this hopefully will be a little more entertaining. And anyway, so you can find this on GitHub at tspharaoh.com or get TangentStorm tspharaoh. Glamorous Toolkit is at gtoolkit.com. That's this whole thing that you can download. So with those two things, you can duplicate everything you see on the screen. I will check this in. And then just one last thing. This had nothing to do with anything, but when I was dealing with this this thing up here, this is your moment of zen, by the way. If you, I was saying, well, I was illustrating this, and I was moving this over here to say, well, this is what Smalltalk does, right? And I was showing with significant white space what these two were, and it reminded me of this thing. So if you like interesting programming languages and you have a sense of humor, I would strongly suggest you Google Dreambird. It's on Dreambird, right? And because if you, for example, look for up here again, it's adding extra characters. Dreambird has significant white space. Use space to specify the order of arithmetic operations. So 1 plus 2 times 3 is 7, and 1 plus 2 times 3 is 9. And I think that's awesome. Dreambird is the future. So I will leave you with that.